Hello class. Today we're going to talk about Module 6, which deals with optimization problems. And optimization problems are nothing more than just a fancy way of saying word problems, where our word problems will focus on things such as maximizing or minimizing something like an area, or we want to figure out when we're given the rate of change of one thing as it relates to another thing, and we want to find out the rate of change of the other thing, how we could actually do that. And so I have three examples here that's somewhat similar to the homework that you've done. And so I just kind of want to give you a feel for how to go about solving these particular problems. So let's go ahead and get started here. So the first problem that we're going to do will be a maximizing type of problem. And so our problem says here that if we were to grow plants in a rectangular shaped garden with a perimeter of 52 feet, what is the max area we can achieve? Okay, so looking at this, the very first thing that we notice is that the perimeter of a rectangle is the sum of all the sides. So in keeping in that, we know that to express the perimeter here, we need to say this side here with the x, we know that this is x as well, and we know that this side is y. So we know here that 2 times x plus 2 times y has to end up equaling 52 feet. Okay. We also know that the area of a rectangle is just length times width, or in this case x times y. Our goal here is to be able to come up with a function for area in terms of x, and I'm just choosing it. We can do it in terms of x or y. And then after we find out this particular function here, we want to take the derivative of it and set it equal to 0. Now the reason we want to do that is because we're trying to maximize the area. So based upon what the length of side x is, there may be some lengths where the area is increasing, and there may be some areas where the area is decreasing as we continue to move x. What we want to do is pinpoint the place where the rate of increase or decrease in the area with respect to side x is 0. That means it stops increasing, it stops decreasing. Okay, and that's precisely where we think we will have a local maximum. And so that is our strategy here. Now, in order to get this area function here, we notice that we have two variables, x and y. We need to change y and rewrite it as a variable of x. And we're going to use our perimeter equation in order to do that. So here we see that since 2x plus 2y is equal to 52, we can subtract 2x from both sides, and we'll end up getting here 2y is equal to 52 minus 2x. Okay? And then we can divide both sides by 2. And when we do that, we end up getting y is equal to 26 minus x. Okay? And so now we're going to use that and plug it into our equation for area. So therefore, we see that a written in terms of x will be x times 26 minus x. And if we multiply that out, we see we get 26x minus x squared. So now we have this, and we know that just to give you a general idea of what's going on here, and I'm going to rewrite this, we know that this particular function looks like a parabola opening down. And we want to find out what is this point right here. because at that point we'll get the maximum area. We'll know the length that we need in order to achieve the maximum area, as well as what the maximum area will be. So, but first we need to figure out what the derivative is, because once we take the derivative and set it equal to 0, it'll tell us where this local maximum is. So we take the derivative of this function, and looking at it here, that'll be 26 minus 2x. And so that implies if we take that and set it equal to 0 here, that this will be 26 minus 2x, which is equal to 0. We add 2x to both sides, and then divide both sides by 2, and we see here that x is 13. And this is actually going to be x max. And what I mean by x max is the x value, or the length of that side of the rectangle, that gives us the maximum area. Okay? And so now that we found that, we can figure out what the maximum area will be. And so all we have to do now is take our original function and plug x max into it. And so this will be x times 26 minus x, where x is equal to x max, which is 13. So now we'll just plug that in. So I have 13, 26 minus 13. And so that's 13 times 13, which is 169 square feet. So we know that if the length of side x for the rectangle is 13 feet, then the max area that we can achieve for this particular rectangle will be 169 feet. And so in turn, just looking at it here, we can kind of figure out what the other sides will be. Okay. All right, so that is our first example.